Hello friends, this video on atom and molecules part 8 is brought to you by examfear.com. No more fear from exam. Now let's talk about molecules. We talked about atoms, we talked about atoms a lot, we talked about the size, we talked about the mass, we talked about the way you represent atoms, the history of atoms. We talked about a lot for atoms. Let's talk about molecules. What is a molecule? We told that two or more than two atoms, they are chemically bonded. Example, if you see, sometimes one also, for example, this is a helium atom. It exists independently, or argon. Two, for example, oxygen or hydrogen. Right? Three, ozone, good example of this. Right? Four can be phosphorus. Four phosphorus atom combined to form P4. It can be 6 also. For example, sulfur, A6. So there are so many examples. Right? So, or for single, you can have ions also. You can have charge. It can be but let's talk about molecules, we're not talking about ions now. Okay. So these are examples. Copper is also one example. So molecule are two or more than two atoms, or sometimes one also, one plus atoms combined chemically. Okay. And when you say combined chemically or chemically bonded, I mean to say they are tightly held by attractive force. So there is a force of attraction between these two oxygen, which is holding these two oxygen atom together. Right? These two oxygen, there is a force of attraction. We'll talk about these in the next class. And we know that most of the atoms, they can't exist independently. Right? Because oxygen atom alone is not stable. It's not stable. And why it is not stable, we'll try to study in the next class when we talk about atoms in details. Or maybe in the higher classes. So most of the atoms, they don't exist independently, but they exist in this form of molecules. Okay. So with this, a new definition of molecule can be defined as the smallest particle of element or compound that is capable of independent existence. Right, add molecule are smallest particle of element or compound that is capable of independent existence. Right? And these molecules also show the property of that particular substance. So let me write, and shows all the properties of that substance. This is the definition of molecule. Right? So atom of same elements or different elements can form molecules. For example, it may not be same. Example I took, for example, water molecule. Right? This is a molecule where I have hydrogen and oxygen. This is ozone, we have all oxygen, and this is water where we have oxygen and hydrogen. There's so many examples of molecules. Chlorine molecules, two chlorine together. Right? Hydrogen molecules I have taken. So number of atoms in a molecule is called atomicity. For example, in this case atomicity is 1. In this case there are two molecules, atomicity is 2. In this case 3 atoms, atomicity 3. Here also 3. Here is 4. Sulfur 6. 6 atoms, atomicity is 6. So atomicity Atomicity is nothing but number of atoms in a molecule. It can be monoatomic, for example, the helium, argon, copper, they are all monoatomic because it has only one atom. Okay, it can be diatomic, triatomic, tetraatomic, hexaatomic. That is a term given is atomicity. Atomicity is nothing but number of atoms constituting a molecule. One molecule is composed of n number of atoms. So n is now atomicity of that particular molecule. For example, we talk about methane, CH4. So there are 5 atoms. So atomicity is 5. Okay. Let's talk about the molecules of compounds. In fact, here the topic was molecules of elements. I should not take H2O because it is actually a compound. Right? These are all elements. Oxygen, ozone, this is a compound. So we'll talk about the molecules of compounds now. So molecules of compound, again, different elements joined together in definite proportion as per laws of constant proportion to form molecules. For example, H2O if you see, NH3 if you see, CO2 if you see. So here this is H2O, hydrogen and 2, oxygen and 2 hydrogen. It H2O. And they combine in a different, in a fixed proportion. For example, in this case 1/8, ammonia 14/3, carbon dioxide 3/8, and this is ratio by mass. Okay, this is water. So if you see water has hydrogen and oxygen, and in a fixed mass 1/8, 1:8 ratio by mass. So this is molecules of compounds. Nothing great in this. I talked about molecules. No, molecules were neutral. Now we have ions. Ions are similar to molecules, but they have charge. For example, in this case, again, this can also be single, or no, it can have 2, 3, or 4. It can have different charge. For example, negative charge can be Cl minus. Positive charge Na plus. Examples I am telling you. Right? So example of Ce2 plus. So many examples. The compounds which are made up of metal or non-metal, they contain charge, and they are called ions. So these are generally metals or non-metals, and typically you will see that metal will bear positive charge and non-metal will bear negative charge. Calcium has positive charge, sodium has positive charge, chlorine has negative charge. Okay. Or let's take oxygen. Let's take this is oxygen also. Oxygen also has negative 2 charge. Okay. So the one with the positive charge is called cation. The one with the negative charge is called anion. Anion is a negative ion. A negative ion. So if you take a negative ion, it becomes anion. Okay. So for example, if I have NaCl, it will have Na plus and Cl minus. If you take sodium chloride, it's common salt in water. The moment you put in water, they will break into Na plus and Cl minus because they are more stable. And this sodium ion is a chloride ion, and Cl minus is an anion, and Na plus is a cation. Or if you take CaO, so it will break into Ca2 plus 2 minus. This is a cation, and this is an anion. And this metal ions can have, need not be a single, atom. It can be multiple atoms. For example, this is SO4 2 minus. This is minus 2 charge. Right? This is NO3 minus. For example, HNO3, this is H2SO4. So these are all examples of an ion. So an ion need not be a single charge atom. It can be group of atoms with net charge. It has to have net charge. And these are called polyatomic ions. There's a term for this. Polyatomic ions. So by now we know atoms, we know molecules, and we know ions. We have a fair idea about atoms. Inside atom, whatever we have, electrons, protons, neutrons, we'll study in the next class. For now we know what is atom, what is molecules, and what is ion. So with this, let's try to write some chemical formulas. So this is the example of chart for ions. If you see, sodium exists as Na plus, potassium K plus, silver Ag plus, copper Cu plus. In fact, copper also exists as Cu2 plus. We will see that in the next higher classes. Magnesium Mg2 plus, calcium Ca2 plus, zinc Zn2 plus, iron Fe2 plus. Iron also exists as Fe3 plus. So we see here copper existing as Cu2 plus, Cu3 plus. Right? Similarly, iron exists as Fe2 plus and Fe3 plus. Hydrogen exists as H plus. Hydrogen also exists as H minus. Chlorine as Cl minus. Typically, bromine, iodine all as minus. Oxygen generally exists as 2 minus. Sulfide 2 minus. Nitrite 3 minus. If you see, all these are typically non-metals. And these are typically metals. Right? And these are example of polyatomic ions. For example, NH4 plus, OH minus, NO3 minus, SCO3 minus, CO32 minus, SO32 minus, SO42 minus, PO4 minus. These are all polyatomic ions. I told you ions can also exist as polyatomic. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.